Hi guys, this is the bell ringer for today. You're given a graph and you're asked to find the x-intercept, y-intercept, slope, and equation, okay, for the graph on the left. So go ahead and pause the video and see if you remember how to do that, and then you can come back and check your answer. All right, so let me make this a little bit bigger. Let's go with 200%. And so here you're asked to find the x-intercept. And remember, that's the x-intercept is where the line crosses the x-axis. So that's right there. And that point is 2 comma 0. Okay. The y-intercept is where the line crosses the y-axis. That's this point right here. And that point is going to be 0 comma negative 1. Again, remember the form x comma 0 for x-intercept and I'm sorry, 0 comma y for the y-intercept. All right. So that's how you write an ordered pair. The slope, again, just find two good points and use rise and run. I have 2 points right here already, the x-intercept and the y-intercept. So all I'm going to do is draw my triangle. I go up 1, and then I run 1, 2. So my rise is 1, and my run is 2. And because I went to the right for my run, remember, if I go to the right for my run, it's positive. If I rise and go to the left, it's negative. So my slope is positive. And then my equation, remember the equation is y is equal to mx plus b. And here my slope is 1/2. We already identified that. And the b, the y-intercept is negative 1. All right. So my equation is going to be y is equal to 1/2 x minus 1. All right. So that was the bell ringer today. So let's move on to today's lesson. All right, today's lesson is rate of change. And before I start, I want you guys to go to Canvas, or you can pause the video, and I want you guys to go to deltamath.com, delta, D-E-L-T-A, delta math, and it's .com, all right, and com. And once you go there, go to students and register, right? It's going to ask you for the teacher code, which is right here. The reason I'm doing this, from now on, we're going to start giving homework through Delta Math. It's a better platform for that. And so I want you guys to do that. So let's go on to today's lesson. Today's lesson is rate of change. And rate of change is very similar to slope. Okay, the only difference, right, is between slope and rate of change is the unit. Right, that's the only difference. And you'll see what I'm talking about later on. Don't worry about this right here. Just remember, the only difference between slope and rate of change is the units. Okay, so let's look at, before I go into that, into some examples, let's look at this right here. Um, on this graph to my right, if you notice, right, we have the x-axis and the y-axis, and so when we find the slope, right, it doesn't have any units on it. Now, for rate of change, we would normally name the axes, and so, for instance, I might put minutes on the x-axis and say distance in meters on the y-axis, right? So now my axes are labeled. So when I find the slope, it's going to be the rate of change. And so if I find the slope right here, I don't know. Let's say the slope is 2/3, right? Now it will be 2/3 minutes meters per minute, meters per minute. And you see what I'm talking about in an example. All right. So again, without the units, we have the slope. With the units, we have rate of change. All right. Hope I didn't confuse it there. Let's look at some examples. Okay, wrong slide. Let's go back to this one and say, here's an example. You're asked to find the rate of change from a table. Okay, so let's make it a little bit bigger. Okay, so we can do the change, the delta change, or I can pick um, 2 points. So remember the delta change, the delta y over delta x is the same as I've been doing y2 minus y1 over x2 minus x1. Okay, the same thing. And so let's pick our 2 points, right? It's going to be, let's go with 0, comma 150. So my first point, and my second point, let's make it 2, comma 250. All right. And so let's label my points. This is my x1, this is my y1, this is my x2, and that's my y2. And so if we use the slope formula, which is m is equal to y2 minus y1 over x2 minus x1. I'm just going to plug in the values. So my y2, right, is going to be 250 minus my y1 is going to be 150, and that is over my x2, which is 2, and my x1 is 0. See, it's the same process as finding the slope. Here we're finding the rate of change, but as you can see, the steps are very similar to finding the slope. Now, the only difference now, we're going to add the units. Now, this is my y column, this is my x column. So for the y values, right, we have money, and we use the units, dollars. All right. So on the top, I'm going to have dollars here. And on the bottom now, right, the units is month. So I'm going to put month on the bottom. And that's the only difference. And so we can go ahead and simplify this. If you notice here, if you use the delta change, this is going to be 100, and this is going to be 2. And so we have, that gives me 250 minus 150, that's 100. And 2 minus 0 is 2. And that is dollars per month, over month. Okay. And finally, if we simplify this, that gives us $50 per month. So that is a rate of change. Okay. All right. Let's do the graph. And so let me erase this to get some more space. All right. Let's see my eraser. Let's erase. I need some more space. Oops. All right. So here we go. So I have a graph, so I'm going to pick 2 good points. I call them pretty points. That's where the line crosses the hash mark. And so if I can go with 6, comma 0, and I can go with the y-intercept, which is 0, comma 40. And so if I draw my triangle, all right, I'm going to go up 1, 2, 3, 4. Now I got to be careful now. Each unit is increasing by 10, 10, 20, 30, 40. So actually, I'm going to buy 10, 20, 30, 40. Got to be very careful on that. And then I'm going to run 1, 2, 3, 4, 5, 6. So this is 6, and this is 40. My rise is 40. So rise over run is going to give me 40 over 6. And my units for my rise, right? For my rise on the y-axis, it is, you can't see clearly, but it's cubic feet. Feet, cubic feet. All right. And so that's feet cube on top. And on the bottom now, it's minutes. I'm going to abbreviate that to MIN. And so we can simplify 40 over 60 to 20 over 3 feet cubed per minute. Again, just to clarify, same process as finding the slope. The only thing difference is I'm adding the units. And the units we get from the from the y on the x-axis. All right. Okay, let's move on. Okay, before we're going to go into some word problems, but I want to illustrate something. Okay, so let's say this is 1, 2, 3, 4, 0 is right there. This is 1, 2, 3, 4. Okay, now if you look at this graph, right, you can see that the y-intercept is 3. So this is my y-intercept right there. And you remember the slope-intercept form? That is y is equal to mx plus b. Now, b right here is your y-intercept. B right here is a y-intercept, all right? And so let me say, so b is my y-intercept. Let me do this. B is my y-intercept. Now, there's another term we use for the y-intercept, and it's called the initial value. Initial value, because if you look at the graph, right, at 0, the graph starts at 3. Okay, so that's why the y-intercept is called the initial value, because at 0, right, that's where the graph starts. And you're going to see how that plays into when we do word problem. Okay, so remember, another term for y-intercept is the initial value. All right, let me zoom in a little bit so you guys can see this a little bit clearer. So here, Jessica is trying to save up enough money to buy a bike. She has $50 already in her piggy bank, and she plans on working by mowing lawns for $10 per hour. And ask you what is the rate of change. Now, when you have word problems, if you see any term per day or per month, all right, anything per, that's your cue. That is the rate of change. Okay, and the number is the slope. Okay, so if we look at the equation now, y equals mx plus b. Let's see if we can plug in the values for m and b from the word problem. Here it tells you she has $50 already in her piggy bank. So she's starting off with $50. That is her initial value, right? So that would be B. So 50 would be the initial value because that's what she's starting off with her savings. And then the rate of change, M, right, is going to be 10. 10 is going to be your slope right here. So that's going to be 10. And so if you're asked to write an equation that models example 3, that would be y is equal to 10x plus 50. All right. All right, let's look at example 4. Very similar. All right. I want you to pause the video for a second and try to figure out what is your initial value, what is the b, and what is the rate of change. Okay, let's look at the problem now. Kelly gets paid $25 for just showing up. Right. So when she gets to the house, she has $25. So that's going to be her initial value. That's going to be the B. And then they pay her $10 per hour. So that's going to be the rate of change. That's going to be M. So here we can see that M in the equation is going to be 10. And my initial value, the y-intercept is going to be 25. Right? So the question asks you what is the rate of change. So that's going to be $10 an hour. Right? So let's write the equation now. Y is equal to, we know m is 10, so it's going to be 10x plus 25. And the question is, what is the rate of change? That is $10 per hour. All right? That is the rate of change. But if they ask you what is the equation for the situation, it is y equals 10x plus 25. All right, let's look at this one. Ask you what are the key features. Well, let's look at the x-intercept. The x-intercept. You can go and first go and pause this video and try solve this and come back and look at your answers. All right. Okay. Welcome back. So the x-intercept is going to be 4 comma 0. That's right here. My y-intercept is kind of blurry, but you can see it's at -2. So I'm sorry, that's my slope. My x-intercept is 4 comma 0. That's not my slope. All right, and my y-intercept is going to be 0 comma -2. My slope now, let's find our slope. I'm going to use these 2 points because if you notice, they're good points. They crosses the hash mark. So let's draw my triangle. I'm going to go up 1, 2. So my rise is 2, and my run now is going to be 1, 2, 3, 4. And that can be reduced to 1/2. It is positive because I went up and to the right. If I gone up and to the left, my slope would have been negative. Okay, just remember that rule. And so my equation now is going to be y is equal to 1/2 x, and my y-intercept, right, is -2 minus 2. Okay. All right. Look at 5 and 5. I mean, these 2 examples here are word problems. If I can, let me make this smaller. View zoom 100. Where's my button to scroll? Okay. Something's wrong here. Let me bring this down a little bit. Oh, there you go. Okay. All right. So write an equation of the following scenario. Okay. I'm going to pause. Go ahead and pause the video. Read number 6 and try write the equation, and I'll come back and check your answer. All right. So read the equation, right? Read the problem and pull out the key piece of information. Right? Emily gets paid $4 for just showing up to watch her sister's dog. So that's her initial value, $40. So B is my initial value, and that is 40. And then she gets paid $25 per day. So that's going to be a rate of change. So your M is going to be 25. And so remember the equation y equals mx plus b. And so let's replace the substitute these values now. So y is going to equal to 25x, and my b is 40. All right. Okay. Again, number 7. Okay. My initial value, right, is going to be b is going to be 1500. That's my initial value. And my M, the rate of change, is going to be $30 per hour. $30 per hour. And so my equation is going to be y is equal to 30x plus 1500. All right. And I think that's the last one. Okay, good. All right, guys. So that was today's lesson on rate of change. Tomorrow is a review. Go to Canvas. I'm going to put the link to the review, right? Each period has their own code, so make sure you pick the right code. And good luck tomorrow. I'll see you tomorrow.